like to open up by describing some basic modeling capabilities. Since we all know unidimensional IRT, I'm going to be flying past the following slides really quickly, but just keeping in mind that there might be some notational changes. Anyway, so the unidimensional models in FlexMert, you could really think of it as a sort of a very general version with different kinds of link functions. So there are linear predictors combining the latent variable with other parameters, and they go into these link functions. The 3-parameter model has this pseudo guessing parameter, and it's got a linear predictor inside this logit here. This is very familiar. The way that internally FlexMert handles the estimation is that the guessing is reparameterized. It's like how multilog did this for a long time, that it's reparameterized into its own logit, and then it does not estimate the A and C parameters using the original slope and threshold form. Instead, it estimates intercept and slope. This is because the program will be, it is a multi-dimensional program, a multi-level program by definition. And it is just simply most natural for us to be estimating the intercepts and slopes. For unidimensional models, to the extent that it's possible, we internally compute these derived, in our view, derived parameters like the B values. The B values are simply a very simple transformation using the C's and A's. B is equal to -1 times C divided by A. And those conversions are provided, including standard error conversions, are provided automatically for you. But just keep in mind in general that the internal parameterization can be a little bit different if you're coming from an older generation of software programs like BiLogMG and ParseScale. Oh, and of course, 2PL and 1PL, they're just special cases here. For multiple categorical models, the graded model, for example, this adjacent category logit type of difference, and we estimate more than one intercepts, but fundamentally you build up a graded response model from a more fundamental 2-parameter kinds of model describing the cumulative logits. And for the nominal categories model, this is the original Bach formulation, and the important insight provided by Thyssen, an important paper in Psychometrica by Thyssen and Steinberg, is that you could, in fact, put constraints on the 4-rank nominal model and obtain specialized versions, such as the generalized partial credit model. And that's used very widely in educational measurement and popularized by the ParseScale program. It is a special version of the general nominal model, so you can estimate it as such. And of course, FlexMert, to make it easy, we also have special keywords for you to estimate a GPC model. And you can put further constraints on the GPC model to invoke certain Roche type models, such as the partial credit model. And those models have equality constraints on the discrimination parameters. So, in terms of building up the model, the IRT models that FlexMert handles, we do it through the lens of maximum marginal likelihood. So we adopt this approach by first by writing down the conditional probabilities of all of the item responses. And then as the next step, we integrate out the latent variables to arrive at the marginal probabilities of response pattern. And then these response pattern probabilities get summed up, and they're turned into this marginal log likelihood. And we optimize this marginal log likelihood using either Bach-Aiken or Markov-Chain Metropolis, Hastings, Robbins, Monroe to optimize it, or using the same likelihood, but with Bayesian, put on a Bayesian lens, you use MCMC to find posterior samples of those structural parameters, that is the IRT A's and C's and group means, group variances, and so on and so forth. So, but at the end of the day, the probabilities are formulated using this conditional and marginal formulation.